Hi everyone, so this video is going to be short and complementary to the PowerPoint. So you're not watching this video instead of the PowerPoint, go through the PowerPoint, watch this video, or vice versa, but this is going to be very quick. Alright, so your lesson for today is looking at temperature and heat energy and how that relates to the three major states of matter, solid, liquid and gas. So I thought I would get this simulation started. So here we have a chunk of ice, which is currently at negative 252 degrees Celsius. And as you can see, the individual particles, the individual water particles, are not really vibrating very much. This is because they have a low temperature, and the temperature basically measures how much these particles are vibrating. So what we can do to increase the temperature is we can apply heat energy. Okay, so if we apply heat energy, we're going to create a fire here, and then heat energy is going to transfer from this fire into our container, into the water. And you'll see here that the temperature rises as we apply heat energy into this system. So when the temperature rises, I want you to keep note, have a look at what happens to the particles. Okay, so we still have a chunk of ice, but you can see that the particles are moving a lot more. This is because they have more heat energy and a higher temperature. So this heat has come from here into the water and raised the temperature of the water. Now, we all know that the melting point of water is 0 degrees Celsius. So let's get the water up to about 2 degrees-ish. There we go. And our chunk of ice starts to melt. So what's happened here is that we have applied enough heat that the vibration of the particles is enough to turn it into a liquid. And we increase the temperature a bit more, up to about 50 odd degrees. And you can see it is a liquid form. So these particles are moving freely, but they are still constrained in this kind of mass. And in order to free up the water particles from their liquid form, we need to increase the temperature over 100 degrees. So let's apply some more heat to 100 degrees. We'll make it 117. And you start to see water particles turning from liquid into gas. And if I add more heat, I'll increase the vibration of the particles by giving them more heat energy. So this is basically what temperature looks like. Temperature is a measurement of how much the particles are vibrating, how fast they are moving. And they move faster when we apply heat. So if I try to cool this down, I will be taking heat energy from this system out to outside the bucket. So I'll cool it down. It's going to take us a while because it went quite hot. But you can see as the temperature is dropping, the speed of the vibration of the particles is slowing down. And as we drop below 100 degrees, it will turn into a liquid form. And then when we get below 0, they will become a solid. And when we get back down to absolute 0, the vibration almost stops.